So what we're going to do next is we're going to review Unit 1, and then we'll review Unit 2 and take a quiz over that material. And then we'll do the same with Unit 3 and Unit 4. So we're going to kind of jump around in the Unit 1 at the beginning of your spiral. So if you will flip to page 12 at the beginning, section 1.3, and what we're going to do is we're just going to pick different examples that would have been study tools for the final. So if you look at the bottom of page 12, and all of this should be review. We've done this before, so it might be been a while. So this question says to perform the operation, then state the domain of the following combinations. Remember that your answers need to be in interval notation. So this question right here is asking to add the f function with the g function. So I'm going to rewrite it as f of x plus, sorry, not the g function, the k function. So what that means is you're adding the f function with the k function. And you may or may not be able to combine like terms. So when I substitute in, I'm going to put everything in parentheses. And then I look and see, is there any like terms that I can combine? And the answer is no, because the radical of the x plus 2 cannot be combined with the 4x minus 1. So I'm going to put the 4x minus 1 out front. Then the question asks us to find the domain. So we have to think through on these functions, what's the possible domain for, if you look at it in pieces, if you look at this chunk right here, this is a line. We know that the domain of a line is all real numbers. But when you look at the one on the right, the square root, the domain is not all real numbers. We cannot take the square root of negative numbers. So what we need to do is take that radical. So for our domain, we're going to set our radical, the x squared of x plus 2 has to be greater than or equal to 0, because we can take the square root of 0. And we're going to solve this. So we square both sides, and then we get x alone. So your domain has to be from negative 2 to positive infinity. So remembering interval notation, negative 2 to infinity, and negative 2 has a bracket on it. So the middle one, the f of x over g of x, so f of x is the square root of x plus 2 over the g of x is just 2x. So there's no simplifying that we can do on that one. So the domain, if I look at my domain, we know that we cannot take and have a 0 in the denominator. So if I set for my domain 2x equals 0, you know that x cannot equal 0. So that's one number that's not in the domain. Now we also said we can't take the square root of negative numbers, so we can actually incorporate the domain from the previous example. So this is saying it's all the numbers from negative 2 to infinity, but skipping over 0. So, whoops. Yep, negative 2 to 0. We're going to put a parenthesis. We don't want it to include 0. Unioned with 0 to infinity. So in words, that is saying all real numbers from negative 2 to infinity, and it's skipping over 0. So g times k. So we're going to take 2x times 4x minus 1. So we're going to distribute 8x squared minus 2x. You know that this is a quadratic, and with a quadratic, the domain of all quadratic functions is all real numbers. And the last one, we're going to subtract the g function, which is 2x, with the k function, and I'm going to put it in parentheses so I make sure that I distribute that negative through. So 2x minus 4x plus 1, which is negative 2x plus 1. This is also a line. And if you look back at the beginning, both functions were lines. They're both, if you graph 2x and you graph 4x minus 1, those are both linear functions. So the domain is going to be all real numbers. Okay, flipping the page, we're going to look at this a little differently. We are going to use the table and the graph to perform the combinations. So when you look at, I'm just looking at just this table right now. Don't look at these ones over here to the right. So this question says to evaluate f plus g of 1. So what this means, another way to write this, is f of 1 plus g of 1. So if we go to our table, go to the f row, and it's saying when I input 1, what do I get? And the answer would be I'd get a 7. Then I do the same thing, I go to my g function. Okay, so I go to the G row, and I go an input of 1, output would be -2. Then you add your results together, and you get an answer of 5. So looking at the next one, we are going to look at the G function, and we're going to evaluate. I'm having a little bit of trouble with erasing here. Okay, so we're going to do G of 3 minus F of 3. So go to your G row, look at the 3, G of 3 is -5, minus F of 3 is 10. So then we get -15. So look to the right, and we're going to look at the graph now. And don't look at the table, we're just looking at the graph. Okay, so we're using the graph for part C and D. So it says to evaluate f of -1 times g of -1. So I go, make sure you pay attention, the f function is the one that's going down and to the right. So I go to -1. The f function is +4. And then I go to -1, my g function is -5. So we get a -20. Okay, so the next one, f of 3 over g of 3. So we're going to go to our f function at 3, and that would be right here. And so that would be -2. And then the g function at 3 would be 5, so we get a +2/5. Okay, so next go down to the bottom of this page, and we're going to look at compositions. We're actually going to plug in numbers, not looking at a chart. So the first one says evaluate h of g of 5. Another way to write this would be h of g of 5 like this. So we're going to plug 5 into the g function. So we get 5 plus 2, which is h of 7. And then you're going to plug 7 into the h function. So 3 times 7 minus 1 gives you 21 minus 1, which is 20. This next part, you're going to evaluate f of g of x. I'm going to write f g of x. And then we're going to do the same thing. We're going to do the reverse and do g of f of x. And we're going to compare, are they the same? So f of g of x, so f, I'm going to write the g function down of x plus 2. And then I'm going to take x plus 2, I'm going to plug it into the f function. So I would have the square root of x plus 2 plus 3, which is the square root of x plus 5. So I'm going to go evaluate the next function. G of the f function is the square root of x plus 3. And then if I plug that into the g function, I get the square root of x plus 3, all plus 2. So don't combine the 3 and the 2. So they are not the same. And then we look and find the domain. So we talked about a little bit ago, we can't take the square root of negative numbers. So if we take the square root of x plus 5 and set that greater than or equal to 0, we see that our domain is going to be from -5 to infinity. The function on the right, if you set the square root of x plus 3 greater than or equal to 0, you see that your domain is going to be from -3 to infinity. Flipping the page to page 14, we're going to now evaluate the composition of functions with this table. So I'm going to rewrite this as f of g of 3. So what we need to do first is we need to find what G of 3 is. So we go to the G line. G of 3 is going to be the number 4. So then we evaluate f of 4. So I go to my f function. The 4, its output is a 7. Okay, next line, rewrite it. G of f of 1. So we're first going to evaluate f of 1, so go to the f row, the 1, the output is a 1. Then we're going to evaluate the G of 1, which would be an output of 2.